got some type of love.
Swadika, good afternoon, good morning to those who from Europe and Africa. My name is Rose Chitanwat. I'm going to be the moderator for the session today. Welcome all of you to the webinar, which is organized by Informa Markets together with APC. You have seen the video from APC already. You will hear a lot of interesting things from APC, the expert and the experts that we have together today. Today, I'm going to be your moderator, and if you have questions, please drop in the chat box or the question box. Then I will manage to ask to the specialists who will be in the panelist today. Today, the topic will be on the trends in the Asian aquaculture sector and new strategies to improve productivity. I will be with you all together for 2 hours, and we're going to have altogether 3 speakers and followed by the Q&A session. For the first one that I'm going to introduce to you is our guest speaker from APC, Mr. Ramesh Subramonian. He is going to present about the introduction about APC. Who is APC? Today is my third opportunity to be the moderator for APC Group. It is very interesting product development and innovation that APC put together in place to offer for the industry, both livestock and aquaculture. So may I now invite Mr. Ramesh Subramonian. He is the Director of Sales in Asia Pacific for APC, and he's responsible for business development. He has 23 years experience in business development and management experience in the feed business. So I have now Mr. Ramesh with me. May I pass the stage to you, Ramesh? Hi, Ramesh.
Hi, good afternoon, Rose. How are you? Can you see the
I give the
screen?
stage to you. Yeah.
Thank you very much. And,
all right.
And good afternoon, everyone. Thank you for joining this webinar. So this, as Ms. Rose said, we did the first webinar on swine nutrition, and then we did the poultry nutrition, and this is our third webinar on aquaculture. So we have some interesting speakers, as Rose said. So before that, I think it's important to set the stage and give you an overview what APC do globally, as well as in the region in Asia Pacific. APC is part of the Lauritsen Group, which is a privately held company founded in 1975. We are headquartered in Ankeny in Iowa, in the US. The group has about 60 production facilities worldwide and 2,400 employees. The focus of the organization is on value-added protein technology. And we do that by extraction and fractionation um, of proteins from complex biological fluids, and how to scale it up. Uh, the promoters of the company has been in the business longer time. We crossed 100 years. They started with a dairy creamery in the 1916. Currently, the group has the business focus in human nutrition and animal feed ingredients. The Lauritsen family has 7 companies, which are in different focus areas of the business, and APC is one of the largest businesses that we have under the umbrella. To speak about APC, was formed in 1981, so we are over 40 years in the business. We are also based, our headquarters is based in Iowa in the US. We are now the world's largest manufacturer of spray-dried plasma functional proteins. And we have global network of sales and marketing operation. We cater to the production of livestock production as well as to the agro businesses. The cornerstone of our success has been our commitment to research and innovation. We have 2 innovation centers, one in the US in Iowa, and second is in Spain, where Dr. Javier is based and he is the head of the R&D. And we also do collaboration work with some of the leading universities to do our applied research. So the products that we are going to focus today is basically on two type of product. One is the plasma, and second is the red cell or the hemoglobin powder. The brand name is quite popular, and in some countries it is synonym with plasma. So AP920 has been the brand name of plasma. You can see both the powder form as well as the granulated form. We did a rebranding exercise this year, and it is now renamed as Amplify 920. From the plants that we source it from Spain, if you get the product, it is known as AP820. So depending on where the product is coming from. And the hemoglobin product, it is known as AP301, and it has been rebranded as Fortify 301. We also have in the granulated form. Those of you who knows APC, they know that we have been pioneering in the swine nutrition side, and it goes into the piglet diet, and it's very widely accepted in the nursery diet and in the transition period, and also to overcome immunity and other reproductive to enhance immunity and to overcome reproductive stress. We also have the application in poultry for the early chick nutrition stage in the first 7 days or 14 days, depending on your feeding regime. In aquaculture, where we are talking today, we are one of the largest suppliers of highly digestible protein. Our hemoglobin powder is very well accepted globally. We are one of the largest producers. So, and we will hear more about that from the speakers today. We have a big application for the pet foods, both in the cat and dog food, both in the wet and in the dry pet food segment, with big businesses in Europe and in US. In North American market, we are in the calf milk replacer business, and we also have products which cater to the agronomy side into fruits and vegetables. So just to give you some more insight about what is plasma, and in 2008, the American Society of Animal Science did a survey among the top nutritionists in the world to identify which are the top 10 discoveries in swine nutrition in the last 100 years. And in that, plasma came number 6. So that says, the importance of plasma in nutrition. APC is also the founding member of the North American Spray-Dried Blood and Plasma Produce Association, and we are also part of the European Animal Protein Association. APC has been granted over about 20 patents in the United States and in Europe related to the collection, processing, and feeding of blood and plasma proteins. All these have resulted in over 500 peer-reviewed publications and articles relating to the mode of action, safety, and efficacy of plasma protein in different species. So one of the common questions we get is, how is plasma made? So The process that we follow is the WHO guidelines, which is similar to the human blood transfusible plasma, same process. And we have several virus inactivation steps, which are quite robust to ensure that the product that you get is safe. All the countries have different norms in terms of auditing the plant. So each country, when they have to import, the regulatory authorities visit our plant, audit it, and they also audit after a couple of years to ensure that they meet the standards. So we ensure that product that comes to you is safe, is traceable, and is species pure. We deploy blockchain technology to ensure that the complete traceability through the value chain. We have a global presence, and if you look at our production facilities in the US, we have 7 production facilities spanning over the United States as well as in Canada. Most of our products which comes into the Asian market, especially the plasma, comes from the Canadian plant or from the US plant. We also have production facilities in Europe, in Northern Ireland, which is part of UK, and in Poland, in England, and in Spain. We also get a lot of products from these plants, especially from Spain, into the Asian market. So as you could see that we have either bovine or porcine plants. So depending on the country's regulatory approval, we bring the products from the respective countries. From the Latin American market, we get a lot of the hemoglobin powder from mostly from Argentina, and as well as we have a plant in Brazil. In Asia, we have our office in Japan, but also we operate through a series of long-standing distributors in each of the countries. So we are present in more than 10 countries in Asia. We completed 25 years of our presence and in Asia, and we would like to take this opportunity to thank our distribution partners and customers for their support and in growing this business. If any of you would like to know where the product is available in each of the country that you are based in, and if you want to know the specification sheet or the price quotation, we'll be happy to do that. Or if you want to get any of the technical information from these presentations, we'd be happy to share with you. Hope you have a productive 2 hours with us. Thank you very much.
All right. Thank you very much, Mr. Ramesh, for the introduction about APC. So right now, ladies and gentlemen, you already know about APC a bit from the video and the explanation by Mr. Ramesh. So now from the topic that we are going to present today, it's all about aquaculture, how to improve the production. We now here have the very well-known speaker with us. He is Associate Professor Dr. Niti Chuchird. He is holding the PhD in molecular biotechnology from Hiroshima University, Japan. And he's currently an associate professor at Aquaculture Business Research Center in Kasetsart University in Thailand. Dr. Niti also provides consulting service for many feed business around Southeast Asia. I myself know Dr. Niti as well, very long time, and he's really well known and very specialized in the aquaculture sector. So right now we have him with us here. He's going to cover on the current status and problems in shrimp farming industry in Thailand. Let us learn from Dr. Niti. สวัสดีค่ะ Dr.
Hi, Rose. Thank you very much.
I pass the stage to you. All right.
Hello, everyone. Today, I'm going to talk about the current status and problems in shrimp farming industry in Thailand. My topics will cover the current status, the problems and concerns, study on the plasma protein as a fish meal replacement in shrimp feed. First, I would like to show you this graph about the global farm shrimp production in 2019. I would like to thank Mr. Robin McIntosh from CP Foods for this information. Last year, the global farm shrimp production was around 3.8 million metric tons, and 70% of the production came from Asia. So what about the major demands of the international shrimp markets? Last year, the demand for shrimp from major international markets was around 2.6 million metric tons. For that of 2.6 million metric tons, USA and EU account for 70%, followed by China with 23% and Japan for 7%. Let's take a look at the USA market. For the USA market, the major exporter to USA was India with 41%, followed by Indonesia, Ecuador, and Vietnam. For the European countries or EU, the major exporter to EU was Vietnam with 15%, Ecuador 14%, Argentina with 11%, and India 10%. And for China, the majority of shrimp from that export to China was from Ecuador with 45%, followed by India, Vietnam, and Thailand. And for the Japan market, the majority of shrimp exported to Japan was Vietnam with 25%, followed by India, Thailand, and Indonesia. So from this information, the top 3 major exporters in the world was India with 24%, Ecuador 19%, and Vietnam with 10%. So for the current status of shrimp industry in Thailand last year. In Thailand, last year we produced 274,000 metric tons, and we export 65% of our production. Our major importer market was USA, followed by Japan and China. As I mentioned earlier, that the supply of shrimp last year was around 3.8 million metric tons, but the demand for shrimp was only 2.6 million metric tons. So the main problems of shrimp industry at the moment is we are oversupply. So if you look at this graph, it's about the shrimp price in Thailand from 2016 to 2019. In this graph, you can see that last year, the average price of shrimp in Thailand was the lowest in the past 7 years. That's because oversupply caused the price to go down. And for the situation of shrimp industry this year, as you know that we have a problem with the global economic crisis for a couple of years, but now with the COVID-19, make it even worse. And it impacts on the price of shrimp. We believe that the demand will be stable, but buyers press for lower price. So therefore, farmers have to find a way to reduce the cost of shrimp production. However, in some area, for example, in Thailand, some farmers cannot reduce the cost of shrimp production because the outbreak of disease. So farmers have to stop farming, and we believe that will cause the shrimp production this year will be less than last year. If you look at this graph, this is the projection of the global shrimp farm production from this year. The information from Mr. Robin McIntosh, CP Food, is predicted that the production of shrimp this year will be 3.2 million metric tons, or 16% less than last year. And for the production of shrimp from Asia will be around 400,000 metric tons less than last year. Okay, I will show you the Thailand shrimp production from 2012 to 2019. In 2012, Thailand produced 540,000 metric tons of shrimp. At that time, we are the world #1 shrimp exporter. But in 2013, the shrimp production from Thailand dropped by half because of the outbreak of early mortality syndrome, followed by white physis syndrome. And these two diseases caused serious loss for shrimp farmers in Thailand from 2013 until now. So if you look at the production of shrimp in Thailand last year, we produced only 274,000 metric tons. Let's take a look at the most serious disease in Thailand. The first one is early mortality syndrome, or EMS. The second one was white physis syndrome. For early mortality syndrome, or EMS, scientists named this syndrome as an acute hepatopancreatic necrosis disease, or AHPND, APEN. The cause of this disease caused by bacteria Vibrio. This bacteria can release the toxin and destroy the hepatopancreas of shrimp. So infected shrimp show signs of white hepatopancreas or pale hepatopancreas, and shrimp die very fast. We can find the clinical sign of the disease after 5 days after stocking until the harvest. So to prevent or to control the EMS disease in Thailand, farmers have to use the larvae that free from this bacteria. And during the culture period, they have to have a system to prevent the contamination of this bacteria into the shrimp pond. So second disease is white physis syndrome. This disease caused serious loss in many shrimp farms in Asia, especially Thailand, Indonesia, India, Vietnam, China. At the moment in Thailand, many farms have a problem with white physis syndrome. This year, from my point of view, I think more than 80% of Thai shrimp farmers cause problem with this disease. For the white physis syndrome, signs of white physis syndrome in shrimp farm, you can see white strings of shrimp physis floating on the surface of the water. The shrimp from the white physis ponds show signs of white gut, loose shell, and gradually dying. At the present, we don't know exactly the cause of white physis syndrome, but there are many factors involved. For example, high organic matters, low dissolved oxygen. We suspect that quality of feed may be involved with white physis syndrome. The signs of white physis syndrome in the farm can happen after 20 days after stocking until the harvest. For the key concern for shrimp farming in Thailand, farmers prefer larvae from fast growth broodstocks. Okay, I would like to show you this table. It's about the growth rate of Pacific white shrimp in Thailand. Back in 2010, farmers in Thailand had to culture for 3 months or 90 days to get shrimp to the marketable size of 16 to 18 grams. And the average daily growth rate at 100 days was 0.19 to 0.23 gram per day. But in the past few years, farmers had to culture only 2 months to get to the same size of shrimp, and the average daily growth rate of shrimp at 100 days in Thailand is 0.3 to 0.4 gram per day. You can see that the growth rate of shrimp from Thailand increased a lot. Let's talk about the advantage and disadvantage about the fast growth shrimp. For the advantage of fast growth shrimp, they have faster growth rate. So farmer can culture with a short period of time. As I told you, shrimp farmer can culture only 2 months, they can get shrimp to the marketable size. And the farmer believe that, okay, the short period, they culture only short periods of time. And so this can reduce the risk of shrimp farming. But I don't think so, because when shrimp molt, it's easy for them to get infection. This is the disadvantages of the fast growth shrimp, because shrimp molt frequently. Every time when shrimp molt, they have to use a lot of energy, and after molt, it's easy for them to get infection with any pathogens within the pond. And sometimes the fast growth shrimp, if something wrong with the water quality, for example, not enough minerals in the water, you can see shrimp die. As you see in this picture, shrimp die in the feed tray after molt. So to culture fast growth shrimp, shrimp farmers have to provide a good water quality and stable environment for shrimp. For example, in this picture on the left, you can see that this farmers need to supply sufficient oxygen in the pond, because the fast growth shrimp, they eat all the time. So they need a lot of oxygen for their metabolism. Farmer need to have a system to control organic matters within the pond, so that farmer can control the number of pathogenic bacteria in the water. Otherwise, if they have pathogenic bacteria contamination in the pond, shrimp will get infected and die. So as you can see on the right picture here, this is a shrimp pond with central drain at the center of the pond. And you can see how large of the central drain compared with the human here. He was washing or cleaning the central drain. Okay. Farmers have to use this central drain to pump out the feed leftover and organic matters in the pond out every day. To do all of this, that make the cost of shrimp production in Thailand higher than other exporters, especially India and Ecuador. And so now we cannot compete with the price of shrimp from India and Ecuador. To culture the fast growth shrimp, farmer should provide a good quality shrimp feed. The feed must be easy to digest absorb and store as energy in the hepatopancreas of shrimp. But now we have a problem with shrimp feed because buyers set a standard to reduce fish meal in shrimp feed no greater than 8%. So feed producers must seek the alternative to replace fish meal in shrimp feed. So soybean meal is the most popular choice because the price is cheap. However, high inclusions of soybean meal can cause abnormality in the hepatopancreas of shrimp. As you can see in this picture with the red arrow, this is the abnormal of the hepatopancreas tube compared with the normal hepatopancreas tube here. So this picture came from the shrimp that was fed with the high inclusion of soybean meal. And you can see on the right side is the histology of the hepatopancreas of shrimp, show signs of sloughing of the hepatopancreas cell. And for when shrimp had abnormal hepatopancreas, shrimp will stop eating and weaken. So at that time, if there are any pathogens within the pond, shrimp will get infected, especially Vibrio bacteria. And after that, after they got infected, they will show signs of white physis syndrome and shrimp gradually dying. So to prevent the white physis syndrome, the first and most important thing to use good quality feed. Farmers should have a good feeding program to control the feed leftover within the pond. They should have a system to reduce organic matters in the pond and supply enough oxygen in the water. So to do all of this, shrimp farmers in Thailand have to invest a lot. And with the price of shrimp like this, they cannot make a profit. So at the present, many shrimp farmers in Thailand, they have to stop farming. Let's move to my last topic. It's about the study on spray dye plasma in shrimp feed. This study was conducted at our laboratory a couple months ago at Kasetsart University, Thailand, about the effects of plasma on growth performance, condition of the hepatopancreas, and immune response of Pacific white shrimp. Pacific white shrimp post-larva 12 was stocked at the density of 80 shrimp per tank into the fiberglass tank. In this picture, you can see the post-larvae of Pacific white shrimp on the left, that's used in this study, and we stock this shrimp into the fiberglass tank on the right picture. For feed preparation, 5 experimental groups with different concentrations of plasma protein were studied with 4 replicates per group. Let's take a look at the experimental feed formulation. First, I would like to thank Dr. Prisha Ektamasut and his team from TRF Feed Mill for providing the feed formulations and all raw materials used in this study. In this study, we fixed the concentration of fish meal at 7.63%. And for the control group, we used soybean meal at the concentration of 25%. And for the treatment group, we replaced soybean meal with spray dye plasma protein at a concentration of 0, 1.5, 3, 4.5, and 6%. Shrimp were fed 4 times a day for 45 days. And after that, the growth performance was monitored. 10 shrimp from each experimental group were sampled and checked for immune response, including total hemocyte count, phenol oxidase activity, bactericidal activity, phagocytosis activity, and superoxide anion. This shrimp also used to study histological of the hepatopancreas. The next experiment is the challenge test with Vibrio parahemolyticus. 30 shrimp from each. After 45 days of feeding, we collected 30 shrimp from each experimental tank and put to the new glass tank. Vibrio parahemolyticus at a concentration of 10.5 CFU per ml was put into the positive control group, plasma 1.5% group, plasma 3% group, plasma 4.5% group, and plasma 6% group. Except for the negative control group, we did not put the bacteria solution into it. This concentration of bacteria is the LD50 concentration that killed 50% of shrimps after 4 days. And after 4 days challenge trial, the mortality rate of shrimp was monitored. 10 shrimps from each experimental tank, experimental groups were sampled and checked to confirm the bacteria infection. This shrimp also used to study the histological of the hepatopancreas. Okay, let's take a look at the results. For the survival rate of shrimp, after 45 days feeding trial, shrimp that were fed with plasma 4.5 and 6% had a significantly higher survival rate compared with other groups. For the growth performance, after 45 days of feeding with different diets, we found that shrimp that were fed with plasma 4.5 and 6% show the best average body weight compared with other groups. This picture represents the shrimp from each experimental group. You can see that shrimp that were fed with plasma 4.5 and 6% had bigger size compared to other groups. For the feed conversion ratio of shrimp after 45 days feeding trial, shrimp that were fed with plasma 4.5 and 6% show a significant lower FCR compared with other groups. This table shows feed intake, protein efficiency ratio, and feed efficiency ratio of shrimp. Interestingly, we found that shrimp that were fed with plasma 4.5 and 6%, they had more appetite for food compared with other groups. So they had higher feed intake than other groups. For the protein efficiency ratio, we found that shrimp that were fed with plasma 4.5 and 6% had a significantly higher protein efficiency ratio than the control group and the group that were fed with plasma 1.5%. And for the feed efficiency ratio, we found that shrimp that were fed with plasma 3%, 4.5%, and 6% had a significantly higher feed efficiency ratio compared with the control group and the group that were fed with plasma 1.5%. Let's take a look at the immune response of shrimp. As you know that shrimp is a primitive animal, so that they don't have antibody. So for the immune response of shrimp, if the shrimp had a problem with the bacterial infection in their body, they will send the hemocytes to go there to kill the bacteria. If there are many bacteria in their body, they will send more of hemocytes to surround the bacteria and release the enzyme to kill the bacteria in their bodies. So in this case, if they have high amount of hemocyte count in their body, that means they have higher immune response. So the first immune parameter that we monitor was the total hemocyte count. In this study, you can see that shrimp that were fed with plasma 3, 4.5, and 6% had a significantly higher total hemocyte count compared with the control group and the group that were fed with plasma 1.5%. The next immune parameter study was the phagocytosis. When shrimp send hemocytes to get rid of bacteria, they will have a phagocytosis process to kill the bacteria. So in this study, we found that shrimp that were fed with plasma 3, 4.5, and 6% has a significantly higher percent phagocytosis compared with other groups. The next immune parameter study is the phenol oxidase activity. As I told you that when shrimp send the hemocytes to get rid of the bacteria, to kill the bacteria, they will release some enzyme to kill the bacteria in their body. One enzyme is phenol oxidase. So when we monitor phenol oxidase test, we found that the shrimp that were fed with plasma 3, 4.5, and 6% had a significant higher phenol oxidase activity compared with other groups. The next immune parameter study was the superoxide dismutase. When hemocytes shrimp go to kill the bacteria, they will release this enzyme to kill the bacteria. And we found that shrimp that were fed with plasma 3, 4.5, and 6% had a significantly higher the superoxide dismutase compared with other groups. And the last immune parameter study was the bactericidal activity. This immune parameter is the amount of serum of shrimp that can kill the bacteria. So in this study, we found that plasma 3%, the shrimp that were fed with plasma 3, 4.5, and 6% has the best bactericidal activity compared with other groups. So for the immune study, we found that plasma 3, 4.5, and 6% has the best immune response. Let's take a look at the challenge test. In this study, after challenge test with Vibrio parahemolyticus for 4 days, we found that shrimp that were fed with plasma 3, 4.5, and 6% had a significantly lower average mortality rate compared with the positive control group and the group that were fed with plasma 1.5%. Let's take a look at the results of histological study. For the histological study of the hepatopancreas of shrimp, there is no difference between the hepatopancreas condition before challenge test. However, after challenge test with Vibrio parahemolyticus, we found that the hepatopancreas of shrimp from the negative control group show no signs of bacterial infection. They have a normal hepatopancreas. However, the group that were infected with Vibrio, for example, the positive control group, we found a sign of sloughing, heavy sloughing of the hepatopancreas cells. And we can see we found a sign of serious bacterial infection, as you can see in this yellow arrow in this picture. Okay, when the shrimp had a problem with the bacterial infection, they will send hemocyte into this area. You can see the hemocyte of shrimp surround the bacteria, and then they will release the enzyme to kill the bacteria, like this. And for the hepatopancreas of shrimp that were fed with plasma 1.5%, a sign of heavy sloughing of the hepatopancreas was found, as well as a sign of serious bacterial infection, yellow arrow, just like in the positive control group. Shrimp send the hemocyte to surround the bacteria and release enzyme to kill the bacteria. So you can see a sign of melanization here. For the hepatopancreas of shrimp that were fed with plasma 3%, we found signs of serious sloughing of the hepatopancreas, and as well as in the group that were fed with plasma 4.5%, signs of heavy sloughing of the hepatopancreas was found. However, in the hepatopancreas of shrimp that were fed with plasma 6%, we found a signs of sloughing of the hepatopancreas cells, but the condition of the hepatopancreas of shrimp from this group is better than other groups. For the water quality parameters during 45 days feeding trial. During 45-day feeding trial, we try to maintain the water quality parameter within the suitable range for shrimp culture. For example, pH, we maintain pH at 8.3. And for the dissolved oxygen or DO, we maintain DO no less than 6 milligram per liter. For ammonia nitrogen, we maintain the ammonia nitrogen not over 0.4 milligram per liter. And for nitrite nitrogen, we maintain the concentration of nitrite nitrogen in the pond not over 0.3 milligram per liter. So for the conclusion of this study, we found that plasma protein at the concentration of 4.5% and 6% can enhance the growth rate and the survival rate of shrimp. Plasma protein at the concentration of 3, 4.5, and 6% can improve immune response and enhance the survival rate of shrimp after infection with the Vibrio parahemolyticus. We also found that the histology of the hepatopancreas of shrimp in this group show a signs of lower degree of sloughing of the hepatopancreas cell. So, in my opinion, I think plasma protein at the concentration of 4.5 or 6% can be used as a good alternative for fish meal replacement in shrimp feed. Thank you very much.
ขอบคุณค่ะ thank you ค่ะ Dr. Niti. So you guys have a lot of questions through during Dr. Niti present on his presentation. So we will come back and let him answer later on after the next speaker has complete. So right now I'm going to bring you to the next speaker who is the specialist on the spray dry plasma and how spray dry plasma can promote health and growth in aquaculture. I'm going to introduce you to Dr. Javier Polo. He is the Vice President from R&D of APC. He has about 30 years experience and focus on effort on discovering mode of action of blood derived for protein. So right now I have Dr. Javier with me. So I'm going to pass the video to Dr. Javier to cover on the presentation of spray dry plasma and red cells to promote health and growth in aquaculture. Dr. Javier, สวัสดีค่ะ
Good afternoon, everyone.
Good afternoon.
If it is a pleasure for me to have this opportunity to talk about the use of spray-dried blood product in the aquaculture diets. As Ramesh already introduced to all of you, these are the ingredients that we are going to talk today. Basically, everybody knows about the use of spray-dried plasma, AP920, now with the rebrand is Amplified 920, and the use of spray-dried red cells. And now the new name is 45301. We can take a look about the composition of this product. In the case of spray-dried plasma, the difference between amplified AP920 or amplified 820, as you can see, this is the level of protein. AP920, the level of protein, the minimum is 78. In the case of 820 is 73. And this is because the AP920 is a nanofiltrated plasma that have less ash compared with AP820. Lysine level is basically similar in both of them. As you can see, and for the formulators, for the nutritionists, they need to take in account that spray-dried plasma have a low level of methionine. But other than that, have a very high level of lysine, very high level of leucine. Okay. In the case of spray-dried red cell, 45AP301, you can see this impressive. The level of protein is 92% spray protein, very low level of ash, and the lysine level is very high. It's 9%. In fact, a lot of producers are using spray-dried red cell as a way to reduce the use of lysine, synthetic lysine in the diets, because the level of lysine is very high, as the level of leucines is very high also. Okay, you need to take in account when you are formulating with AP301 is the low level of methionine and isoleucine. Then the first part of the presentation, I'm going to focus in the spray-dried red cells, and the second part will be with spray-dried plasma. Spray-dried red cell is a nutritional ingredient for aqua. As I mentioned before, has a very high level of protein, 92%. Is very uniform nutrient composition, 9% lysine again, and a very consistent amino acid profile and composition. This allowed the producer to have, because it's very consistent, to have a very low nutrient composition, very reduced variation in the nutrient composition. It's a very palatable product. This means that fish diets containing EP301 have a very high feed intake. Again, it's very high level of protein. This provides formulation flexibility for the nutritionists. very digestible, you will see, very soluble. This means that you can use, you can take the advantage of this, of the digestibility of these ingredients for the nutrition of your fish. And compared with high quality fish meal, you will see it have equal or better nutrient composition. Therefore, it's an alternative ingredient for the formulation. How to use? Well, in fin fish feed, basically it's used to replace fish meal. Also, obviously, you can replace soy protein, improve amino acid balance and diet digestibility. Inclusion levels, usually the most common is between 2 to 8%, is the most common. And in the case of shrimp feed, spray-dried red cells is typically used at level 2 to 4%, you can say. And also it's a very attractant and palatable ingredient for shrimp. This is the main reason why it's used in shrimp. Also, you will see provide a uniform dark color, natural dark color to the feed with the use of red cell, because it's a very red product, okay? This is all studies conducted years ago in salmon. You will see that the digestibility of the energy is basically around 90 to 94%. The digestibility of the protein in this study was 98.5. It's almost 100% digestibility. Very high digestibility. Very few proteins have this level of digestibility. This was in trout. In 2000, it's a mistake in the reference, it's 2000. The protein digestibility compared with the control diet, in this case, was almost 90%, statistically better. This is a study that was conducted in 2018 in Italy. There was 12 chover tanks containing 15 fish, each of them. 4 weeks study with the first 2 weeks as an adaptation period. And there was 3 diets in this case, a control diet containing 40% high quality fish meal, or a spray-dried red cell diet consisting of 70% of the control diet plus 30% of spray-dried red cell. And the blood meal diet was exactly similar to the spray-dried red cell. Instead of using 30% of spray-dried red cells, they use 30% of blood meal and 70% of the control diet. When you analyze the digestibility of the test diet, you can see that the blood meal have a lower digestibility compared with the control. Remember that the control diet was fish meal, and this was the diet with spray-dried red cell, was the best from dry matter point of view. When we analyze the crude protein, both the control diet and was fish meal or the spray-dried red cells have the better digestibility of the protein compared with the blood meal. Okay. When we analyze, this was the digestibility of the whole diet. When we analyze the digestibility of the test ingredients, in this case, blood meal or spray-dried red cells, you can see the digestibility of the red cells was 90% in dry matter compared with 40% in the case of blood meal. Or in case of crude protein, the digestibility of the blood meal was around 50% compared to higher than 90% protein digestibility in case of spray-dried red cells. This is a study comparing the performance in tilapia. In this case, there was the comparison compared with fish meal in the control diet versus 8% spray-dried red cells in the experimental diet. You can see the weight gain was significantly improved, and the gain to feed, remember the gain to feed, the higher the better, was better in the case of spray-dried red cells. Therefore, as summary about the use of spray-dried red cell, that is very common in the aquaculture feeds, I would say that is the use of spray red cells in aqua is is one of the most common use of red cells of AP301. What is the benefit? As I already mentioned and I already demonstrated in the previous slide, is a very high digestible protein, very high in lysine and other amino acid. For example, it's very high in histidines. Histidine is around 6%, if I remember correctly, and this is very good in the case of salmon or trout to reduce the problem with cataracts. Also have very low level of phosphorus. Then from environmental point of view, it's very friendly. As I showed to you, improve the average the dairy gain and the feed efficiency, improve the nutrient efficiency, and obviously improve the overall performance. Okay, it's a very high quality ingredient for the aqua business. Okay, we are moving now to plasma. The use of plasma in aquaculture. Dr. Niti already covered the last study that we conducted this year about the use of plasma in shrimp, and very nice results. I will cover other studies in fish, but also in shrimp. What is the difference? What make different plasma, spray-dried plasma, respect to blood meal? First of all, is the source of the blood. In the case of spray-dried plasma or spray-dried red cell, this applies to both. Is hygienically collected blood. Okay, the collection is in closed system, very controlled system. In case of blood meal, usually it's floor blood. Blood meal, as you know, is whole blood or can be red cells. In the case of plasma, obviously, is the different fraction from red cell. Okay, but this never is whole blood. It's white product, as you can see. In the case of blood meal, because the collection is not very hygienical, they have a very strong heat treatment. Usually it's 2 hours, 100 degrees with a ring dryer. In the case of spray-dried plasma or spray-dried red cells, it's a very mild heat treatment. Basically, it's 80 degrees throughout each substance. Protein level in the case of blood meal is around 90%. In the case of plasma, or EP920, as I mentioned before, is around 80%. If we put here spray-dried red cells, will be 92, 94%. Okay. Solubility of blood meal usually is very insoluble product because this strong treatment, less than 10% soluble. In the case of blood products, it's much higher than 85. In fact, the normal values is around 94, 95. Obviously, due to this heat treatment, there is not a protein that survives that treatment. There's naturalization of the protein, then there is no functional protein at all. In the case of blood meal, in the case of plasma, yes, because this treatment is not as strong as this one, and then there is more functional protein. The stability, obviously, as for example, in the last study that I provide to you, the stability of the amino acid of the protein in the blood meal, if you remember, was 50. Usually, the amino acid digestibility of blood meal is below 70%. In the case of blood spray-dried plasma, you will see it's higher than 90. And remember that in the case of spray-dried red cell, was most of the time higher than 95%. We want to differentiate what is the difference between protein versus functional proteins, because as you know, proteins is a nutritional source of amino acids. These are all the proteins. Functional proteins are proteins that, in addition to being a nutritional source of amino acids, have a biological action beyond the nutrition. And usually these functional proteins maintain the normal gut function and support the animal health. This is a cartoon about the different protein bioactive peptides, growth factor, hormone, cytokines, amino acids that you can find in spray-dried plasma. Spray-dried plasma is not just one protein. It's a very complex blend of different protein, growth factor, amino acid, hormone, and cytokines. It's, for example, very different than spray-dried red cells, than 90% is hemoglobin. In the case of plasma, no, it's a very complex blend of different proteins, growth factors, bioactive peptides. Okay, this was a study that we conducted. Just we want to know what was the impact of feeding plasma in trouts at different levels. The objective of the study was to evaluate the impact of feeding trouts, different level of plasma, and we had plasma inside or outside the pellet. And the idea was to see what was the effect on performance, intestinal morphology, digestibility. As you can see, there was 5 treatments, a control treatment without plasma, two treatment with 3 or 6% plasma when you add plasma before the extrusion, or 3 and 6% plasma add after the extrusion. Okay, and the idea was to see if the extrusion have a significant effect on the plasma performance. This was presented in 2014. It was a study that was conducted in the United States. And as you can see here, the diet digestibility was improved when you put plasma. Doesn't matter if you put plasma inside or before the extrusion or after the extrusion, improved compared with the control. And when you analyze, this was the crude protein, and when you analyze the dry matter, also basically plasma improved protein and dry matter digestibility around 3% in this study. The biomass, the higher level of plasma, higher biomass in the study. What we observed, basically higher level of plasma improved the biomass between 9 to 21%. Then, therefore, there was a higher production output in this study. When we analyze survival, also we observed that with the use of plasma, the higher the level of plasma, the higher survival. And as you can see, 6%, there was no difference between putting plasma before or after extrusion. The survival was improved between 4 to 15%. The conclusion of that study was that survival was numerically increased with both inside or outside plasma application, and the crude protein digestibility was higher with the use of plasma in the diet. Then this is a study that was conducted by a research group in Brazil, and they are looking at the effect of spray-dried plasma in the inclusion of diet with Nile tilapia. Okay, in this group that was published 3 years ago, you can see there was 5 treatments between 0 to basically 6.6% plasma inclusion level. Okay, all diets formulated with the same level of energy, same level of protein, digestible protein, and the length of the study was 60 days. Well, when you see the result of the studies, you can see that plasma improved by 13% the final body weight. Was linear. It was a quadratic effect. We can say that after 5% we don't see the benefit of plasma. We can see it in this study that 5% was the right inclusion level. The relative weight gain or average daily gain, you can see it is basically the same effect in the final body weight. It was improved by 15%. And as you can see, 5% was the right inclusion level. When we analyze the specific growth rate, basically was similar than in the previous for the final body weight or for the average daily gain. Linear effect till 5%, and the feed conversion rate was reduced by 11%. And in this case, we have a linear effect, even at 6.6% was a linear effect for feed conversion rate. A clear reduction, very interesting reduction of 11%. When you use this data, and you analyze and you put what is the effect, the economical effect, we conducted this analysis, this economical evaluation by an external advisor, and they were using the price of the ingredients according with the African market and the sales according with the African market at that time, in 2017. And when we are putting here the level of plasma at 5% inclusion level, you can see that at the end of the day, the use of plasma has a benefit, was improved economical evaluation by 20%. After you take out the cost of the ingredients, you take in consideration all the costs in the economical evaluation. This was a study that was conducted in Spirorickettsia, in salmon, that was challenged with SRS, Salmonid Rickettsia septicemia. In this study, basically, we have two groups, or control group, or a group with 3% plasma. All the diet was isoenergetic and isoprotein. The length of the study was 105 days. There was 4 to 7 days of acclimatization. Then there was the feeding for the initial 4 weeks, we can say 28, 31 days. And after that, we was the challenge with SRS, and we keep the animals till day 70, okay? And we follow all the animals for all the period, okay? The objective, the parameters that we analyze is the growth performance, the organ and tissue condition, immune oxidative stress, and survival to the SRS challenge. I can say that, well, for the survival was no difference, probably because the concentration of the pathogen was too high in the tanks. And we not observe different survival for the SRS infection in this study compared with the control diet. Nevertheless, when we analyze the results of performance, remember that this was the initial body weight. This was at 30 days of age. But if we keep the animals till the end, till day 75, basically 2 or 3 days before they diet, because the challenge, this means that these animals were in a very bad conditions because it was challenged, but still we have the data of the performance. You can see that in the control group, there was a big variation between the 3 tanks. In the group of plasma was a very uniformity in the weight at the end of the study, okay? And the increased weight between the initial body weight to the final, you can see it in the control group. There was a lot of variation. In the case of the plasma group, there was a very high uniformity in the weight of these animals. The increased biomass, you can see here the increased biomass. This is S2 at 55 days. You can compare from the initial to the final to day 75. You can see the biomass increase, a lot of variation in the control group, very uniform in the case of plasma group. The specific growth rate, again, and the thermal growth coefficient basically have the same effect than previously. There is a significant effect in a specific growth rate, and significant effect in the thermal growth coefficient. And both groups have, in the case of plasma, have a very high uniformity. And this is very relevant because these animals, remember, that were challenged. This is very relevant to keep this uniformity. Then the conclusion from this study that was presented last year to the Aquaculture America was that plasma did not improve survival in this study, but we observed significant difference in weight, growth performance, and biomass increase at the end of the study, just a few days before the animals diet. This was observed between the control and the plasma group. And the plasma group have, and this is very relevant, have a very low coefficient of variation for the final weight, for the weight and biomass increase, for the specific growth rate, and for the thermal growth coefficient. These are here in Europe. We have been working with Spanish Research Institute, and they are very focused in sea bream, because in the Mediterranean area is a big production of sea bream. Then we have been studying the inclusion level of plasma in the diet for sea bream juveniles. In this study that was published in 2015 in the Journal of Animal Science, with 12 tanks, 4 tanks per treatments. You can see there was 3 diets: a control diet, or a diet containing 3% plasma, or a diet containing 6% plasma. Okay. Diet were isocaloric and isoprotein, and the plasma replaced fish meal in this study. Okay. Well, you can see in this specific study, what we observed was that the inclusion of plasma improved the final body weight. Looks like a quadratic effect. In fact, with this number, I will say 3-4% probably is the right inclusion level. In the case of the final length of the animal, again, there was a quadratic effect with plasma. Okay, the best was a 3% inclusion level, and the improvement, you can see the improvement in body weight was around 10% improvement. In the case of the length was 2.2% improvement. When we analyze the oxidative stress enzymes, you can see that plasma reduced the oxidative stress in the liver and in the intestine. This means that improve the health status of the animals. Again, we have a quadratic effect for most of them. And basically, the studies show that 3% inclusion level was the right inclusion level. You can see if there was a reduction in the catalase, there was a reduction in the glutathione reductase and the other enzymes that we analyzed. This means this reduction is correlated with less oxidative stress in these animals. When we analyze the non-specific immune response, we analyze in this case the lysozyme or the bactericidal activity. You can see that in this case we have a clear effect of plasma, doesn't matter the inclusion level, for both parameters. This means that in plasma increase the non-specific serum immune response, providing protection, potential protection against pathogens. Using this number and doing exactly the same, the economical evaluation, working with 3 of the 6%, and make a calculation with biomass and taking in consideration all the costs, the cost of plasma, the cost of fish, and everything. You will see that if you do the economic evaluation with the 3% of plasma, the potential profit versus no plasma was in this case 15%. In the case of 6%, because half a quadratic effect, was 8% improvement. With this research institute, IRTA, and with the University of Barcelona and Autonomous University of Barcelona, we have been also working to understand better how plasma works. And then we have been working with transcriptomic and proteomic profile. In this second study, we have 2 diets: a control diet based on fish meal, and a diet with 3% plasma. Okay. I'm not going to show you the performance. Performance was exactly the same than in the previous trials. With plasma, there was an improve in the performance, in the body weight and the length. But in this case, we analyzed the gut histology, and you can see it in the global cell density, either at 20 days or at the end of the study. At 95 days, there was an improvement in the global cell density with the use of plasma. With the Billy height was not statistically different, numerically was in the right direction. Okay, this was presented 2 years ago in a congress. And then we take a sample of the kidneys, sample of the skin-associated lymphoid tissue, and sample of the gut-associated lymphoid tissue. We extract the RNA, and then we analyze the transcriptomic of the gene involved in these three tissues. And what we observe is that plasma, compared with the control, have a big impact in up-regulating or down-regulating different genes. In the gut, we observe that 737 genes was statistically different in the animals that were fed with the diet with plasma versus the diet without the control diet. At the level of the kidney, 41 genes were up-regulate or down-regulate, and in the case of the skin, 132. What we are doing now is just to match this difference in the gene expression with the with the expression of metabolites. Okay. For the time being, what we know is that at the epidermal mucous proteome, what we observe is that the results suggest that with the use of plasma, there is an improvement in the response to the stress. There is an increase in the proteolysis. There is an increase in the redox defense. There is more cell metabolism was improved, and the exocytosis and the keratin fragment also was improved. Okay, and we still are analyzing this data, but the results suggest that the plasma is able to modify the inclusion level of plasma in the diet is able to modify the the proteomic and the gene expression in at least these three different tissues of the animals. When if we are moving to shrimp, this was all a study that was conducted in the year 2000. In this case, we have a challenge with white spot syndrome virus, WSSV, and very similar to what Dr. Niti observed. The only difference is Dr. Niti keep the 6% in this study. You can see this is the survival. There was a very strong challenge because the control, any of the shrimp survived. But we observed a very high survival, even higher than 60% with 4% inclusion level of plasma. This was conducted in Japan in 2000. And then there is a more recent study conducted, I think it was last year, using applying plasma before or after the extrusion in the shrimp diets. Okay, this was a study that was presented last year. As you can see, there is 2 periods: first 3 weeks and last 6 weeks. Okay, there was a control group, a group with plasma at 2% inclusion level for the 6-week period, or a group added to the mixer, or the same than previously, but the second period was a control diet. And then there is a group that they add 2% plasma for both periods, but in this case as coating after the extrusion, or the group just put in plasma the first 3 weeks and then the control diet. As you can see, this is the average weight of shrimp at 6 weeks. There is a clear plasma effect compared with the control for all the diets, and looks like, especially when you put plasma in the mixer, looks like that it's better to put for the 6 weeks. When you put externally, in fact, there was no difference between both of them. This was from the study. What the author said, that plasma feed at 2% during the first week of life accelerate the growth. Better conformity of the gut wall morphology was observed. They observed a higher the stability of the total diet with plasma, higher survival, and as I mentioned, plasma works either if you add before or after the extrusion. Okay. This was a study that was conducted in Mexico. was a few years ago, and the field conditions was 3 diets with 4 replicates per diet, tanks with 28,000 liters, 43 shrimp per cubic meter, 3 diets, commercial diet A, commercial diet B, and a diet containing 4% plasma. Okay, all the diets were isonutritional, 35% protein, 7% fat, and isoenergy. Commercial diets A and B, the difference is the level of fish meal. Okay, and the duration of the trial was 42 days. Okay. Well, what we observed was an improvement in the biomass compared with the 2 commercial diets. Feed intake was between these 2 commercial diets. Obviously, the feed conversion, adjusted feed conversion, was improved compared with the commercial diet, and the survival was very high, it was 92%. Similar, for example, that commercial diet A. Then the 4% plasma improved the growth and the feed efficiency, and we observed in this study a high survival. Okay. Then when you put the cost of everything, the commercial diet A or B or the diet with 4% plasma, at the end of the day, when you take out all the costs and you take in consideration the feed costs and everything, you can see that the dollars per hectare was significantly better with plasma compared with that commercial diet B was $1,000 per hectare. In the case of commercial diet A, it was almost 676. Okay, but you can see, well, but in this study, you have a very high survival, and at the time that we conducted the study, the selling price was very high. What will be if we put a normal survival, not 92, 72, 71, 72, and the selling price more according with normal condition. Well, instead of 1,000, obviously the difference are lower, but still you are talking about almost $300 per hectare. Okay. These are just the last few slides. This is a table that summarizes all the studies that has been published about in different species, as you can see here, with different pathogens, not only pathogens, also stress conditions, cold stress, or use water, or smoltification process. And the use of plasma always is correlated with improved average daily gain, improved survival in some cases, less oxidative stress, improved feed conversion rate. Usually this is the common pattern in all these studies. Then the general conclusion is that plasma is a good functional protein for the aqua diets because improved growth and uniformity, improve the intestinal development, reduce mortality. In Europe, it's used as alternative to antibiotic growth promoters. Could be used to reduce the negative effect of bacterial or virus infection. Plasma will not avoid the infection, but will reduce the negative effect. And the recommended inclusion level, as you can see from the different studies, we are talking between 2 to 6 persons. Take-home message is that plasma in farm fish or shrimp submitted to stress condition also improve survival and growth, and in juvenile diets improve growth performance parameters. If you have any question, I will be more than happy to answer. Thank you.
All right, thank you, Dr. Polo. And now I would like to invite all the panelists to open the video in order to have a question. I would suggest the audience, after the Q&A finish, you may go through the Q&A box to see Dr. Niti. Dr. Javier already answered some of the questions in case I could not cover in this next 20 minutes. So right now I have question on hand which have both anonymous audience asking question and person who give the name on asking the question. So right now I have question on hand. I would like to ask Dr. Niti first. The first question from Kun Ek Anand Yuva Benjapon. He is asking how is the difference between white feces syndrome and white feces disease?
Okay. There is no difference white feces syndrome and white feces disease, but mostly when for the disease that we don't know the exactly cause, we will not use the word disease. So we will use a word like white feces syndrome, something like that. There is no difference.
Yeah, all right, that is clear. So next question I believe is to Dr. Niti again on the prevention of EMS, EHP, WFS is very important. So are there any steps to prevent this disease? So this question is there are about 3 persons asking the same question. Dr. Niti, I pass to you.
Okay. First, for the EMS, okay, we know exactly the cause of EMS. It's caused by some strain of Vibrio that that can build up that can release toxin into the shrimp hepatopancreas. And now we already have the primer to detect this toxin and detect this Vibrio species. So first, to prevent the EMS into your pond, especially for the shrimp, before stocking, you have to test the shrimp that to make sure that this shrimp free from EMS before stocking. For example, in Thailand, okay, we have a process before stocking shrimp directly into the pond. Most farmers have to stocking shrimp into a nursing pond, and during the nursing period, maybe 10 to 20 days, it depends on the facility of the farmers. During that period, they have to sample shrimp and test for the contamination of the EMS bacteria in shrimp. If they found some contamination in the larvae, they will destroy all the larvae. They will not stock this larvae into the pond. And during the culture period, they have to have like a treatment pond. They're not pump the water from directly from outside of the pond into the culture pond. They have to pump the water from the reservoir and put the water into the treatment pond. They have to use some chemical to kill the pathogen in the pond before use the water from this treatment pond to replace with the water in the culture pond during the culture period. So this method is used in Thailand to prevent the EMS infection. And for the EHP, this method is difficult to handle because it's very small and it's widespread in the environment. So in Thailand right now, to prevent the EHP, first we have to use the larvae that free from EHP. Before stocking, the farmer have to check the contamination of EHP in the shrimp first, and before stocking shrimp into the pond, you can use lime, put the lime into the pond bottom. You can add up before stocking shrimp, you dry the pond and then pump the water into the pond, maybe around 10 centimeter, and then you put the lime into the pond and create the high pH level at the pond bottom around 10 to 11. If pH at 10 to 11, the spore of EHP will be destroyed. And you can leave it for maybe 5 or 7 days and then pump the water into the pond. That method can kill the spore of EHP in the pond bottom. But during the culture period, you may have a chance that the spore of EHP contaminate to the water and go into the culture pond anyway. So it's very difficult to handle EHP. However, if you can culture shrimp with a low density of shrimp, make shrimp healthier, the problem with EHP on the growth of shrimp will be less. I think that's the best way for handle EHP in the farm. You cannot use chemical to kill everything, every pathogen within the pond to culture shrimp. That is impossible. The cost is too high and you cannot do that. But for white physis syndrome, as I told you that we don't know exactly about the cause of white physis syndrome yet. So they involved with many factors. For example, high organic matter. Because if you have a problem with high organic matter within the pond, you will have a problem with bacteria pathogen to overbloom in the pond. And if something happen for the environment of shrimp stop eating and they will weaken. And then the bacteria that overbloom in the pond can get infect into your shrimp, and you will have a problem with shrimp get infection with loss of VBO and can cause white physis syndrome.
All right.
Difficult.
So in like the summary for Dr. Niti, it's about like the EMS. You have to check the larvae before you're stocking, and also the same to EHP to check the larvae before stocking, and also do the pond treatment like putting lime to adjust that. But however, EHP can come back at any time, so you have to regular checking on your shrimp and your pond because it can contaminate back from the environmental and even the water and even the organic matter. For white feces, ladies and gentlemen, Dr. Niti answer very clear that we really don't know the cause of it. So it is very important to check on the bacteria level and the contamination that may come with the water and with the feed matters. The other question, Dr. Niti, is there any ELISA kit to test this disease in shrimp?
So
Is
now,
any available?
So now we have a PCR primer to check the contamination of the bacteria caused EMS in the shrimp, and even we have a PCR primer to check the toxins of this VBO in shrimp before stocking.
All right, we have like few questions to Dr. Niti already. Now we go to Dr. Javier on asking about the measurement on the FCR of shrimp. How do you do that, and any suggestion?
Well, you're talking about the measurement of what?
Yes.
Sorry, the
Feed conversion rate.
the
FCR.
SCR. Okay, the feed conversion rate is what you are asking. Yes.
Correct, sir.
Okay. Well, probably Dr. Niti can answer better than me because he's
right, so
a nutritionist. But in any case, the feed conversion rate is calculated with the average feed intake and the average feed intake. Basically, it's the average feed intake divided by the average dairy gain.
Dr.
This
Niti,
is the
any
feed conversion rate.
additional answer to Dr. Javier?
Yes, the same. They use feed intake divided by the
Yeah.
feed weight gain of shrimp.
Yeah. Okay. So I think this question was asked because in general to both of your presentation. I have the next question about the nutrient level in the products, the plasma spray dry plasma products. Dr. Javier, can these products replace fish meal?
Well, this is a good point because, for example, in the trials that we have been conducting here in Europe with seabream, but also with salmon, usually plasma or spray red cell is a very high quality protein, and then you try to replace a high quality ingredients. And it's common that the fish replacement will be fish meal. And in fact, with the University of Barcelona, with the group of the seabream trials, basically they are trying to reduce the fish meal to very low level, 7% in the control
So
diet.
meaning still using the fish meal, but
yes,
using this product as well. All right.
yes. Well, there is a lot of studies trying to completely replace fish meals in Norway. Some companies claims that they have they are able to completely replace fish meal. You need to take in consideration that fish meal is a very high quality protein, and then it's a very palatable protein, and then I'm not sure that you can replace completely the fish meal. You can
So I would
reduce significantly.
I
the
would
inclusion level.
recommend that if anyone, the audience here, interested in reformulate your feed for your shrimp or tilapia or your other kind of fish, you can contact Dr. Javier or
Yes,
Mr.
absolutely.
Ramesh to reformulate in your feed formulation. I would put the email ID of both of them in this chat. Okay. So the next question go to the metabolite.
Ms. Rose, I think in Southeast Asia, like in countries like in Vietnam and in Thailand, in all these places, they do the partial replacement of fish meal with use of red cell or hemoglobin powder from us. Yeah. So that is very common.
All right. So for those who ask question, because you didn't mention the replacement, full replacement or partial replacement, Mr. Ramesh already mentioned that it can be partially replacement and it's already well-known use in the Southeast Asia because we are the hub of the fish and shrimp production here. So to know more about it, you can contact any of our representative from APC, and Mr. Ramesh and Mr. Javier is ready to give you answer. So back to Dr. Javier, one more question, sir. On the metabolized energy of plasma and red cell for shrimp, what is the metabolized energy?
The metabolized energy is the energy that the animal is able to metabolize. I think that there is I don't remember now the formula about the metabolized energy, but this is the, if I remember correctly, this is the net energy plus the.
They want to know the exact value.
Yes.
So what we claim in our spec sheet is 3,900 to 4,000 kilocalories per kilos for plasma, and for red cell it's about 3,700 kilocalories.
Okay, that's very clear.
Javier,
it is a figure. Ramesh, can you answer on the Q&A box for this audience so they can claim that the question come about 2:51 p.m. from anonymous attendee. All right. So I will go to the next question. I would read the question first, and probably you suggest me whom should answer this from Mr. From Ken Swan. They ask, he asked about, do Vibrios have tolerance in water acidity? Does it affect its infectious rate if the water acidity is high? So I assume Dr. Niti, right?
Okay. Okay, for this question, for the VBO, they don't like the water with the acidic condition. However, if you have a problem with low acidic condition in the water, for example, the pH of the water less than 7.4, you will have a problem with shrimp molting continuously, because for the physiological of shrimp, they will adjust the pH of the blood as the pH of the blood of shrimp will match with the pH of the water. So if the level of the pH in the water is too low, shrimp will have a problem with acidic in the plasma. So they will molt a lot and shrimp will die because of molting.
Okay, so that's very clear to the question on acidifier. So can we say that acidifier in shrimp can kill VPO at a certain level, doctor?
Yes, just like we have previously we have a test with organic acids, use organic acids to reduce the number of VPO in the guts of shrimp, and we found it's acidic organic acids has an effective substance that can reduce the number of VPO in the gut of shrimp. However, if you put too much of organic acid, the smell is very bad, and we found that shrimp will not attract to the feed, and you will have a problem with like they reject the feed.
Oh, okay. So go to the next question, Dr. Javier. You ready? So it's about your the question come when you present your trial. So can you totally replace soybean meal with amplified AP920?
Well, answering the question, yes, you can completely replace soybean meal, but you need to take in. Here is not a question of replacing completely one or other ingredients. This is a question of making a good quality diet, very digestible diet. Obviously, if you increase, depending on the quality of the soybean meal, if you increase the inclusion level of soybean meal, will be a restriction in the digestibility of the protein, and maybe can have other other problem with non-nutritive parameters associated with soybean meal. The use of plasma basically can help you to reduce this inclusion level of soybean meal and keep a high quality diet, very digestible diet. The objective should be to have a very digestible diet, more than which are the ingredients that we need to replace. It's the same that fish meal. Can we replace completely fish meal? Probably yes, but it's better to partially replace fish meal, because at the end you are looking for the balance of the amino acids. To me, the parameter that you need to look when you are designing a diet is obviously this price, but also the digestibility of the diet.
It's very direct answer that Dr. Javier hit to the point. So considering on the cost that would happen to your feed, so the partially or full replacement is up to your formulation, and check the digestibility of amino acid in your feed. That is common in feed formulation. So come to the question to Dr. Niti once again. So this is probably Dr. Niti already answered to the audience here, but since we have 10 minutes more. I'm going to cover for the other audience here. Is there any way to control VBO of EMS without medication, doctor?
Okay, for the EMS, as you know, in case of to prevent EMS, first before stocking, you have to make sure that the larvae that you stock free from EMS. So you have to sample and check the larvae for the EMS contamination using PCR method, because now we have a PCR primer available to check the contamination of VBO causing EMS and even toxin of this VBO in the shrimp. And for after during culture period, you have to have a system to prevent the contamination of this VBO into the culture pond. So instead of when you replacing the water, exchange the water, you have to have a reservoir and treatment pond. So when you want to replace the water, you have to use the water from the treatment pond that you already use the anti, for example, iodine or potassium permanganate to kill all the bacteria pathogens, or chlorine to kill all of the bacteria pathogens. Before using the water that no contamination of VBO causing EMS, and use this water to replace when you culture shrimp in the culture pond. This method can help reducing the loss of EMS bacteria.
All right, so that is different on the development country by country. Thailand has like more advanced on doing the shrimp farm inland. So a lot of issue handled from experience of Dr. Niti. He can share more on the pond management to prepare for your white feces. You can contact him through the email. So to the next question, Dr. Niti, I still keep asking you because the question is more on white feces in shrimp. There is a question you already answered on typing. White feces in shrimp can be treatment by saponin or not?
No. Saponin is cannot use for treat the white feces syndrome.
All right. So I hope the audience who asked these questions still on the line now. You cannot use saponin for treating the white feces in shrimp. So now we are going to ask about how's the difference of white. Let me ask again. So sorry. To compare the insect protein meal, which one is more suitable to replace fish meal, Doctor?
I cannot answer because I have never have experience to do the experiment with the insect protein as a fish meal replacement.
Ladies and gentlemen, so Dr. Niti haven't tried with insect meal in fish, in shrimp yet. So Mr. Ramesh also answered the same, that there is a functional value on the insect meal ingredient. Tomorrow there will be the session on insect ingredients. So if anyone interested, you can listen from that. And we may link back to the APC because there is a lot of combination of the replacement can be done. So next question I'm going to ask again on EMS, EHP, WFS. The question asked is like, are there any steps to prevent this disease? It's like that is the pattern of the step, or you have any suggestion on that?
Okay. For EMS, you have to prevent the contamination of the EMS bacteria into the culture pond by use larvae that free from EMS bacteria. And during the culture period, you have to have a system to prevent the contamination of the EMS bacteria into culture pond. As I told you that you have in the area that have EMS outbreak, you have to have a treatment pond, and you have, before you use the water for exchange between culture pond, you have to exchange the water between culture pond and the treatment pond that you already treat all of the bacterial pathogens within the treatment pond. This
So it means actually no step. It is like you have to do everything in parallel, right?
Yes, that's right. And for the white fishes, as I told you that we don't know exactly the cause, but mostly when we check the shrimp from the white fishes pond, we found a high infection rate of the Vibrio bacteria. So we believe that Vibrio bacteria associated with white fishes, but they need to have a factor to trick a size of white fishes that happen in the shrimp, and we don't know exactly what is the real trigger or stressor, but we suspect that quality of feed may be involved. Even the quality of feed, what I mean is, if too much of ingredient of feed that shrimp cannot digest and absorb. Okay, in some raw material, if you use to make a feed, when shrimp eat, they cannot absorb. They absorb only a little bit, and after that they have to how can I say, they absorb only a few. The leftover from that feces is the organic matter, and this organic matter can be a food for pathogenic bacteria in the pond, and they can make the pathogenic bacteria bloom. And during microorganism or pathogenic bacteria blooming in the pond, this organism will use oxygen in the pond, and we will have a problem with low dissolved oxygen in the water, and that cause shrimp will be weakened and easier to get infection with all of the pathogens within the pond. So sometimes when you check the shrimp from the white fishes pond, you can have a lot of pathogen, EHP, Vibrio, and lots of bacteria. But when we study the white fishes, when we separate this pathogen and reinfected this pathogen into shrimp, for example, EHP, we found that even with shrimp fed with EHP for a long period of time, shrimp did not show a signs of white fishes, but they may show a signs of slow growth, but not white fishes. But for Vibrio bacteria, we found that in some time when we reinfected with shrimp with the Vibrio, and we stress shrimp first. For example, in our laboratory, we used to do like put shrimp in the low dissolved oxygen level, for example, less than 2 ppm for a couple of days, 3 to 5 days. And then we put the bacteria that we isolated from the white fishes pond. Then we put into the shrimp that we stressed with low dissolved oxygen first. We can create a size of white fishes in our laboratory.
All right. So to answer again, this is like there are few of questions asking on that. So Dr. Niti already clearly say not by step, but you have to do everything comprehensive in the parallel. And again, we are on together to know how white feces is happening and what cause for that. So follow to the Aquaculture Business Center of Dr. Niti. There would be a lot of news coming up. So today I would like to end our webinar here, and I will open this webinar for the audience to come and see the Q&A that answered by Dr. Niti, Mr. Ramesh, and Dr. Javier on the Q&A box. So we are going to open another 15 minutes. So spend your time to read the answer. And on behalf of Informa, I would like to thank you for APC and Dr. Niti, Dr. Ramesh, and Dr. Javier for today. Thank you very much and hope you all have a great experience sharing by all of our panelists. Thank you very much. ขอบคุณค่ะ For the
Thank you.
audience, tomorrow we are going to have the sector on technology innovation development in aquaculture by InfoFish, and we'll have the AFFIA. Follow us with our next webinar tomorrow during Aquaculture Week webinar by Informa Markets. Thank you very much and have a good evening. สวัสดีค่ะ
Thank you.